Alright, hello students. This is a video about reflections. First of all, reflections are one of the many transformations that we're going to be learning about in this unit. And a transformation is a change in position, size, or shape of a figure. So the translations we learned about, rotations, all of those are transformations, including a reflection. Now, there are certain types of reflections, and a certain class of them is called an isometry. So an isometry is a transformation that does not change the size or shape of the figure. So when we have an isometry, that means that the shape that's created is congruent to the original one. So when we have an isometry, that creates congruent figures. So one example of an isometry is a translation, which shifts the shape to another position. We have a reflection and a rotation are all examples of isometries. And then counterexample, if you have the shape but you stretch it, stretch is not an isometry. Dilation, making it larger or smaller, is not an isometry. And any kind of a cutting of the shape or losing a piece, that's also not an isometry. Okay, now on to reflections. A reflection is a transformation across a line such that the line of reflection is the perpendicular bisector of each segment that joins a point and its image. So the line that you're reflecting over has to become the perpendicular bisector of this dotted line that connects a point and its image. So when we say that this line is a perpendicular bisector, what we mean is perpendicular means it forms a 90-degree angle. Okay? And bisector is referring to the fact that the distance from the image to the line is the same as the distance from the original point to the line on the other side. These two distances are equal. Okay, so it is the perpendicular bisector, and those two facts are very important for reflections. Okay, so there's three types of reflections that we're focusing on. The first one is reflecting across the y-axis, and when we reflect across the y-axis, the x value, the y value first of all stays the same, right, because it stays at the same height. However, the x value changes from being positive to negative, or from being negative to positive. So the point xy becomes the point negative xy. When we reflect across the x-axis, the point up here, this time the x values are staying the same, okay? But the y value is changing from positive y up here to negative y down here. So when we reflect across the x-axis, the point xy becomes the point x negative y. And then we can also reflect across the line y equals x. And that line y equals x is your same y equals mx plus b. Okay, it's the same y equals mx plus b that you've learned in the past. The y-intercept is 0, so it goes right through the middle. And then the slope is 1, so you go up 1 over 1. So this is y equals x. It's a diagonal line. When we reflect across that line, actually the x and y values just switch. So if a point was xy, it becomes yx. So the point xy becomes yx. For example, if we were to have the point negative 1, 3, and we were to reflect it across the y-axis, well, that would become positive 1, 3. If we were to reflect the point negative 1, 3 across the x-axis, it would become negative 1, negative 3. The 3 becomes negative. And if we were to reflect it across the line y equals x, the point 1, negative 3 becomes 3, negative 1.